all once again, and welcome to the second session of the day on Basics of Statistics. We have with us as the resource person for the session, Madam Priyanka Dikshit, Assistant Professor and Chairperson of Center for Health and Social Sciences, School of Health System Studies, TISS, Mumbai. Madam, we had already one very informative session with you on sampling size determination. And today we are looking forward for another enriching session and get benefited by your seasoned knowledge. Before we start the session, I would request our Vice Principal, Professor Sandesha Shetty, to introduce the resource person to the participants.
Yeah. Good morning, madam. I'm very honored to introduce Dr. Priyanka Dikshit. Dr. Priyanka Dikshit is an assistant professor and chairperson of Center for Health and Social Science, School of Health System Studies, Tata Institute of Social Science, Mumbai. She teaches in the Master of Public Health, Master of Social Work, Direct and Indirect MPhil and PhD programs. She is a principal investigator of NACO funded project and in past coordinated various national level projects related to tobacco consumption, nutrition status of children and female sex workers. Most of our work is related to MCH, NCDs, evaluation studies and public health issues based on large-scale surveys. She has published more than 30 research papers in international and national level journals. Madam has taken determination of sample size topic on day 3 of this research methodology workshop, wherein she has covered sampling and non-sampling error, absolute and relative error, normal distribution. Practical, very important thing is that she has demonstrated practicals related to sample size estimation. Madam, on behalf of Bansangas SM Shetty College, I heartily welcome you, ma'am.
Thank you, sir. Thank you, ma'am. Thanks for warm welcome. And good morning to everyone, all participants and students and researchers. So today we are going to discuss about the basic statistics. I'll just share my screen, just a minute. Can you all see my screen? My
yes,
screen is visible.
Yes.
Okay, thank you. So, actually we are, first I have explained some complicated part, which was sample size determination. Now today we are going to discuss very basic thing, but this is the base of the entire statistics or entire, we should say, a quantitative research methodology. Yeah. So we are going to discuss today a basic statistics. So if we look at what comes under the statistics and how it has been divided into different aspects or different domain. So broadly, we can say that the entire statistics has been divided into two parts. Yeah. First part is about the descriptive statistics. Another part is about the inferential statistics. Yeah. Now, what is the main difference between the descriptive statistics and inferential statistics? So I hope you all are aware that what is the need of statistics and why actually we are doing a sampling. That has been discussed, I think, in the previous sessions. Okay. So what is the need basically? So actually we have some research question in our mind. Research question can be anything. It can be related to economics, it can be related to public health, or maybe biology, or maybe a geography, or any subject. We have some research question. Let's say my research question is to find out the what proportion of population in Mumbai are obese. Okay, what proportion of population in Mumbai are obese? Means those who are having the obesity problem. Fine. This is my research question. Now what I can do? First, which I have the resources, I have the money. What I can do? I can collect information from all the Mumbai resident, and then I can calculate what proportion of, let's say, if the total population, hypothetical condition, if the total population of Mumbai are, let's say, 10 lakh. So I should collect information of 10 lakh individual, and then I should measure their obesity according to the some standard scale, and then I can find out that what proportion of population are obese. Yeah, but as we know that it is next to impossible for anyone to find out the information of all the individual. So ultimately we have to rely upon sample. Yeah, so we have to rely upon sample. So with the help of sample, whatever sample size we can calculate, as we have discussed in the last session. So what we can do, we can calculate the sample size, and then let's say I have collected 100 sample out of 10 lakh population. I have drawn a 100 population. So what is my aim? My aim is to give the information of entire Mumbai with the help of 100 sample, isn't it? That is my task in statistics or in research methodology. So when I'm saying I have collected information of 100 population, 100 sample, so first my task is to give the information about these 100 people. So I have collected information of 100%, and then I should measure their obesity, and I should write whether the person are obese or not obese. And also there are some other characteristics. There are other characteristics when we are collecting information. We have to ask their age, their sex, their religion, caste, and other socioeconomic conditions. So there are multiple factors will come when we are trying to describe my sample. Okay? So all these comes under the descriptive statistics. I am going to describe my sample. Fine. So I can calculate on an average age of the person, or mean age of the level of education. So I can apply some statistics to describe my data set, describe my sample. So when my task is to describe the sample, in that situation, we are going to discuss about the descriptive statistics. Fine. So with the help of descriptive statistics, we can describe the sample. After describing the sample, what is my next job? I wanted to apply some statistical technique so that I can generalize my sample finding to the entire population. I wanted to predict, I wanted to generalize my sample finding to the population level, isn't it? I hope this is clear to everyone that what is the need of inferential statistics. We wanted to draw inference from the sample so that with the help of sample, we should identify and inform to the people that what is the characteristics and what is the situation of the population. So I hope it is clear that what comes under the descriptive, what comes under the inferential. Descriptive means describing the sample. Inferential means we are going to apply some technique so that whatever finding we are getting from the sample, we should able to project for the population level. Because ultimately I wanted to inform that what is the situation of Mumbai. It's not only my sample I wanted to describe. So this is the major difference between the descriptive statistics and the inferential statistics. Now, when we are going to discuss about the descriptive statistics, fine, descriptive statistics. So there are basically two terms will come. Yeah, there are two things will come. What is that? It's about the measure of central tendency and measure of dispersion. Okay, and before I should start that, I hope you all are aware about the variable and measurement. Is it okay, variable and measurement? the different types of variable we have, isn't it? Anyone can say whether they know about the level of measurement. So variable can be has been divided into four or basically we should say two parts, a categorical variable and the continuous variable, or categorical variable, or maybe we can say a scale variable. So I hope this is clear and has been covered in the previous session. So any variable you can name, any variable. Can anyone give the example of any variable? Yes, any variable. So variable could be, let's say, age of the person. Okay, age of the person. So age of the person is what? If I'm going to ask all the participant age, they are going to say 20, 23, 25, 30. So these are the actual numbers. These are the actual numbers. So when the variables are going to take the actual numerical values, those variables are considered as the scale variable. Okay, scale variable. And there are variable, like if I would ask you belongs to which state, or you belongs to which district, then what you will say? Someone will say I'm from MP, someone would say I'm from Chennai or Maharashtra, like that. So these are the some information which not actually linked with the some numbers. But for the purpose of analysis, we are going to assign some numerical values. So let's say I have mentioned if the person belongs to Madhya Pradesh, I will give 1. If Uttar Pradesh, then I will give code 2. If Maharashtra, then I will give code 3, like that. So what is this? 1, 2, 3, 4. This is the actual numbers, or this is a code? This is a artificial codes. So if the variables are going to take the artificial codes, those variables are considered as the categorical variables. So variable has been divided into two parts, categorical variable and continuous variable. I hope it is clear to everyone. What is the difference? Okay. So now when we are going to discuss about the different measure of central tendency, you have to be very careful. You have to first identify the, what? The type of this one, whether the variable is continuous scale, and then we can choose the appropriate statistics. I'm not sure whether participants are allowed to unmute themselves. Otherwise, we can quickly have this exercise. So can we say that sex is the continuous variable or categorical variable? Can you all say? I'm not sure. I think they are not able to say anything.
And participants are posting in the chat box.
Yeah, in the chat box it's there.
Okay, fine. So which type of variable it is? Sex is a continuous variable or the categorical variable?
You can help ma'am to say.
So we can say it is a categorical variable. है ना? Categorical variable. Height of the person is continuous or categorical? Height of the person. Height of the person is in continuous scale. Yeah. Number of cigarette smoking per day. It's a continuous variable. Whether how many friends you have, it's a continuous variable. Whether you belongs to rural area or urban area is a categorical variable. Yeah. So all these things, all broad statistics which we are going to discuss today, it depends upon whether your variable is a categorical variable or whether it is a continuous variable. So first in the statistics, we are going to discuss about the measure of central tendency. Measure of central tendency. What does it mean, measure of central tendency? Why this name has been given? Why this name has been given? Because we are interested to give information about the central part of the data. Why central part? So it has been observed from the past experience, it has been observed if your variable is in continuous scale, it can be height, it can be age, it can be blood pressure, it can be any continuous variable. If we plot a graph on x-axis, if we take variables like age, let's say from 0 to 5, or let's say blood pressure, if we talk about blood pressure less than 60, 60 to 70, 70 to 80, 80 to like that. If we take on the x-axis, and on y-axis, if we calculate the proportion of population belongs to different blood pressure, what type of shape I will get? I will get the normal shape, bell-shaped curve. Normal shape, bell shape होता है ना, bell shape ऐसे करके. So this shape curve I will get most of the time. You will be very surprised. Most of the time we will get the bell-shaped curve. Fine. Now in bell-shaped curve, what does it indicate? This indicate, if you look at the bell shape, so in the left extreme and the right extreme, the population is very few. That's why the shape is like this. And the majority of the population behave like this part, middle part, where we have the peak. So what does it indicate? That majority of the population behave like this central part. Fine. So if we are talking about the blood pressure, there are very few people whose blood pressure is very low. There are very few people whose blood pressure is very high. Majority of the population blood pressure will be normal range. That is my expectation, है ना? That is my expectation. Majority of the population behave like a normal, and their behavior would be in the normal range. Fine. So that's why, as a statistician, it is my responsibility to give the information of the central part, because majority of the population behavior is like central. So my responsibility is to give the information of the central part of the data. That's why we are going to discuss about the measure of central tendency. Measure of central tendency. Is it clear? Why central tendency is important? Because majority of the population behave like central. So that's why we have to give the central idea about the central part of any distribution. Fine. I hope it is clear. Yes? Okay. So now, so in measure of central tendency, what all comes? We all have learned now since 10th class. Since 10th class, we have learned that what all come in the measure of central tendency? What all come in measure of central tendency? Three things will come: mean, median, and mode. Yeah, mean, median, and mode. Now you can ask why it is needed. Have you ever thought that why it is important that we should discuss three indicators? Why not one indicator is sufficient? That we are going to discuss. Okay, so let's say this example, if you could see. So I have taken 9 individuals who has tested HIV positive. Okay? During, and then I have asked information how many times they have a sexual contact during last 6 months. 9 individual, I have asked how many times they have sexual interaction with their partners during last 6 months. Fine. So first person has informed 2 times, another person informed 4 times, 6 times, 7 times. So this is the information which you can see. Is it fine? Is it okay? Fine. Yeah. So what I have done, I have simply arranged my data into increasing order. Yeah. Starting from minimum to maximum, I have arranged. You can see, है ना? You can see that data is in the increasing order, 2, 4, 6, 7, 8, like that. Yeah. Okay. Now what happened? I am going to calculate the central tendency of this data set. Central tendency. First, I am going to choose the mean. Yeah, mean. So without calculation, I am not going to discuss about the formula. You tell me without calculation, if what is your hypothesis, what is your expectation, where my mean will come? Mean is the central part of just
Ma'am,
yes. Yeah, sorry. So if I would calculate the central tendency and specifically mean, I am not going to discuss as if now the formula. Just from the name, mean is the kya hai? Mean is what? Mean is the central tendency. So when I'm going to calculate the mean, where this should lie? Because it is a central tendency, so where my answer will come? If you look at this data, it should come in the yeah, around 7, around 7 to 8. Why around 7 to 8? Because this is the central part, central midpoint, central part of the data. ठीक है? 2 to 15 में central part is where? Between 7 to 8. Yeah. So my answer should lie in the 7 to 8. If my answer is not going to lie in 7 to 8 or between this central part, then I would say that there is a problem in the mean, or mean is not a good indicator. Fine. So now how we can calculate the mean? What is the formula? It is summation xi divided by n. What is summation xi? Xi is what? Xi is nothing but the number of the values of the different people. So x1 is 2, x2 is 4, x3 is 4. So these are the x value. I am going to add all these value. 2 plus 4 plus 4 plus 6 plus 7 up to 15. Divided by how many observations we have? Divided by n. How many observations we have? We have 9 observation. We have 9 observation. So 2 plus 4 plus 4 plus up to 15 divided by 9. How much we will get? We will get 7.6. If you could see, I have written the answer. It is 7.6. Where 7.6 is lying? Where 7.6 will lie? It lies between 7 to 8. है ना? It lies between 7 to 8. Yeah. So what does it indicate? What does it indicate? That at present mean is the good indicator, na? Because my expectation without calculation was it should lie between the middle part, and when I have applied the formula, I got the around same answer. So mean is the, in this situation, is the good indicator to show the central tendency of the data set. Is it okay? Central tendency of the data set. Now, what is the interpretation? That is important. What is the interpretation? Interpretation is, on an average, sexual contact during last 6 months was around 7.6. Okay. On an average, sexual contact during last 6 months by HIV tested people was 7.8, 7.6 times. Okay, this is okay. So mean is clear. Mean is clear. Fine. Now what we are going to discuss? Okay. Okay, should I give this information? Yeah. Okay. Now let's say we got additional information. Now we have a information of the sex of the individual. Someone else has informed that out of this 9 individual, how many are male and how many are female. So I have prepared the second information, male, male, female, female, like that, if you could see. For the purpose of analysis, I have given code. One is for, if the person is male, I have given 1. If the person is female, I have given 2. Okay? So this is just a code. My question is, can we calculate mean of the sex of the individual? Can we calculate mean of the sex of the individual? You can write down in chat box, yes and no. Someone is saying no, no, no. Okay, majority of them are saying no. Why we are not able to calculate mean of the sex of the individual? Because 1, 2 is not a numerical value. This is the code. This is the artificial codes. These are the, exactly. So this is the categorical variable. We are not in a position to calculate the mean. Hai na? But if you give the instruction and if you apply the in any software will calculate. Okay, software will calculate irrespective whether your data is a scale variable or it is a categorical variable, you will get answer. But it's your choice. You have to give a proper instruction. Then only you will get the meaningful indicator and you are in a position to show and represent your data set. Okay? So this is clear that when mean we can calculate and when mean is not applicable. Yeah. Okay. Now let's say look at the different example. In the same example where I have the information of a 9 individual, I got another information. One person has reported during last 6 months he was having 93 times sexual interaction with partner. Fine. So if you could see my sample sizes, earlier it was 9, now it is 10. And the last person has reported that the sexual contact was 93 times. Is it okay? This data is clear. Fine. Now, without, again, I'm saying, without calculation, can we do it by SPSS? Yes, we can calculate all the indicator using SPSS and Stata and Excel also. Okay? Yeah. So now again my question is, without calculating the mean, don't use the formula. Without calculating the mean, what is your expectation? Where my mean should lie? Where my mean should lie? Write quickly. Central part. Yes. Where is the central part? Again around 7 to 8. Na? Around this one. 7 to 8 is my central part. Around 7. Yeah. Is it okay? Na? Because mean is the central tendency. So it should obviously lie in the central part. If it is not going to information about the central part, then maybe we have to doubt. Okay. So what happened? Now I am going to apply the formula. What is my formula? I have to add 2 plus 4 plus 4 plus 6 up to 93 divided by how many observations we have? 10 observations. 10 observations. Yeah. Divided by 10. How much would be my answer? If you could see, I have written 161 divided by 10. We got 16.1. Where 16.1 will lie? If you identify where it will lie, 16.1 will lie extremely right now, or between 15 to 93. Is it okay? So in this situation, can we say that mean is the good indicator? Can we say mean is the good indicator and it will give us the idea about the central part of the distribution? We can't say. Yeah. So we can't say. So where is the problem? So should we say that mean is not a good indicator? Then why mean is so popular? Mean is the good indicator if we are working on a homogeneous data set. Okay, the conclusion is that if there are some outlier present in my data set, in that situation, we should not rely upon the mean. Mean will not give us the idea about the central part of the distribution. So mean is very good indicator, but it's only applicable if you are working on a homogeneous data set. Homogeneous and heterogeneous, I hope you are able to make out. Okay. So then what should we do? How then I can present the central part of the data set? So that's why there is a need of the another indicator, that is a median. Okay, that's why there is a need of median. So what we can do, how we can calculate the median? Yeah, so what is the median? So median is nothing but, there are two formulas to calculate median. If you all can write down, I would appreciate. So if your series is odd, if number of observations are odd, then the formula of median is n plus 1 by 2. If you could see in the slide, n plus 1 by 2. And if your observations are even, then we are going to calculate two terms, n by 2, n by 2 plus 1, and then we will take an average. Okay. Okay. So, so let's say if in this situation I have to calculate the median. So what my series is, when I have a 10 observations, my series is odd or even? It is even. So which formula I should apply? Second formula. So I have to calculate n by 2. N by 2 is what? N by 2 is 5. Fifth observation, not 5. Fifth position. Then n by 2 plus 1 means sixth position. Okay. So we have a fifth position, we have a sixth position. Okay. So we are, and then we have to take a average. So fifth position pe 1, 2, 3, 4, 5. We have a 7 value, 7. And then sixth position pe we have a 8. I'm going to take an average of 7 and 8. 7 plus 8 divided by 2. How much I will get? 7.5. So what is my median? 7.5. Where 7.5 is lying? Where 7.5 is lying? Between 7 to 8. And what is that part? 7 to 8 part is the central part of the data set. Okay? So you can see that if your data set is heterogeneous or some outliers are present, in that situation, mean, we are not going to prefer the mean. We should believe on the median. We should believe on the median, because in that situation, median will give us the correct idea about the central part of the data set. Is it okay? Is it okay? Yes. Now, now if I'm going to remove the last observation, let's say I will remove this 93. Can you all calculate the median? Calculate and write down the answer in your chat box. If I'm saying remove the 93 observation from this data, yes, or calculate for this series, calculate the median. So what is the formula? N plus 1 by 2. N plus 1 means 9 plus 1 divided by how much? 10. So then how much we will get? 10 by 2. So we will get fifth observation. 1, 2, 3, 4, 5. Fifth position पे क्या है? That's 7. So median is 7. ठीक है? Median is 7. So in this situation, when there are no outlier present, what is the conclusion? When the data set is homogeneous, when outliers are not present in the data set, in that situation, if we apply mean or if we apply median, we will get a almost close result. We will get almost same result of mean and median if your data set is homogeneous. But if your data set is heterogeneous, in that situation, we will get the large difference between mean and median. In that situation, median will give us the better idea about the central part of the data. Is it okay? It's clear about mean and median, I hope. Fine. Now what we are going to discuss, next part is this one. Next part is mode. Now what is mode? So mode is nothing but which values are coming again and again in your data set. Okay, most frequent observations. So if you just look at this data set, which value is coming more and more time? 4 is coming 2 times. All other values are coming only one time. So what is the value? What is this one? Mode is 4. Now what is the interpretation? So can you all write down in your notebook? In this particular situation, your mean was 7.6. Just write down. Mean was 7.6. Median was 7. Mode was 4. Have you all written? Yes, mean is 7.6, median is 7, and mode is 4. Now, what is the interpretation? There are 3 different interpretations. When I am saying mean is 7.6, what is the interpretation? I am saying on an average, 9 individuals have reported 7.6 times sexual interaction during last 6 months. I would appreciate if you all can write. Just write one line interpretation so that in future you can refer and accordingly you can write. Is it okay? Interpretation of mean, on an average, 9 individuals have reported 7.6 times sexual interaction during last 6 months. Fine. My median was how much? 7. What is the interpretation of median? Median used to divide the entire data set into 2 equal parts. Okay. So interpretation of median is 50% observations, 50% people have reported they have less than 7 times sexual interaction. However, 50% of the people have reported more than 7 times sexual interaction during last 6 months. So it's divided into 50-50 part. Okay? Is it okay? Out. So what I'm saying, 50% of the population have reported less than 7 times sexual interaction during last 6 months. However, 50% of the population have reported more than 7 times sexual interaction during last 6 months. Yes, done. Now come to the interpretation of the mode. What is this mode? Mode will say maximum of the participants have reported that 4 times they have a sexual interaction during last 6 months. Maximum participants have reported 4 times sexual interaction during last 6 months. Is it clear? Interpretation of mean, median, mode, and when we can apply mean, when we can apply median, when we can apply mode. Okay, just quick thing. Now we are going to relate with the type of data. If the data is in continuous form, if the data is in continuous form, can we apply mean? If the data is continuous, can we apply mean? Yes, we can apply. Can we apply median? We can apply. Can we apply mode? We can apply. Yeah. So if the variable is captured in the scale form, continuous form, we can apply all type of statistical tool. It's not only limited to mean, median, mode. We can apply all type of statistical technique because the nature of the variable is sophisticated. But if our variable is in categorical form, let's say sex of the individual, can we apply mean? Can we apply median? Median we can apply. We cannot apply median. Why? Median is applicable if in categorical, if the data is in ordinal form. If at present, if I'm talking about male, female, we cannot apply median. है ना? What about mode? Can we apply mode if the data set is in categorical form? Can we apply mode? Mode always we can apply, na? Because mode mein to we have to check which code is coming repeatedly. So whether it is a continuous value or whether it is a code, we can say, yeah. So mode we can apply everywhere. Median we can apply if the variable is continuous or it can be in ordinal form, order form. Mean we can only apply if the variable is in continuous scale. Okay? So this is clear. This is about the central tendency, which is the first chapter of your statistics. Yeah, this is okay. Yeah, okay. Now, should we go ahead with the measure of dispersion? Let's say we have a 3 data set. We have a 3 data set. Data set 1, data set 2, and data set 3. Okay? And just assume this is the blood pressure of the individual. In one data set, I have collected information, I have measured the blood pressure, and fortunately, everyone blood pressure was 120. You have collected 10 different individual, you have measured their blood pressure and you found 90, 90, 110 like that. Third person has again measured the blood pressure, we found 80, 100, 100 like that. We have a 3 data set. My responsibility to describe the data set. So how I can describe? How I can describe? I have to calculate the central tendency. So I have calculated mean, median, mode, and surprisingly, I found that mean and median of both all the 3 data sets are same. There are some changes in the mode, but mode is not that much as a strong indicator in statistics. So when we came to know that mean and median of all the three data set is same, can I conclude that all the data sets are same because their central tendency is same? Can I say? We can't say, because we can see that there are differences in the data set. We can't say that data set is same. So then we need some additional indicator to show some more properties of the data set. है ना? We need some other indicator to show some additional properties of the data set. So what are those properties? So these are those properties are nothing but measure of dispersion. Measure of dispersion. How the values are distributed, dispersed. That is about the measure of dispersion. First, we are talking about the central part, central tendency, and then we are interested to know that how the different values are away from the central part, away from the central part. And that's why we are going to discuss about the measure of central tendency. Okay. So in central tendency also we have a number of indicators. Like in the central tendency, we have a mean, median, mode. In measure of dispersion also we have a number of indicators. Number of indicators. So first very simple indicator is range. With the help of range we can identify how much is the variation present in the data set. How much variation is present in the data set. Yeah. So range is nothing but what? Range is nothing but is the, just you write down the formula. Range is upper limit minus lower limit of the data set. Range is nothing but the upper limit minus lower limit of the data set. Okay. What is the upper limit? If you look at the first data set, how much is the range? 15 minus 2. 15 minus 2, that is 13. How much is the range in the second data set? 93 minus 2, that is 92. So these two things range will tell us in which data set we have a heterogeneity, in which data set we have a homogeneity. So if we compare these two data sets, what happened? We can clearly say that the variation present in the data set 2 is more compared to data set 1, isn't it? Variation present in the second data set is more compared to the data set 1. Yeah. So this is a very simple technique to show the variation present in the data set or measure of dispersion. But you know, this indicator is not the very sophisticated indicator because it just involves the upper and lower limit. It does not include the in between values. So mathematically it is not preferred. So then there is a need of another indicator. So what we are learning, we are going to discuss about the mean deviation. What is mean deviation? Mean deviation formula I have written. What is that? Summation xi minus x bar divided by n minus 1. What is xi? Xi is nothing but different values of x. Yeah. And x bar is nothing but the mean. Okay? Mean of the data set. So let's say, so what actually we are trying to calculate in mean deviation? So if you just look at the numerator part, x minus x bar means what? So let's say we have a different x values. If we talk about blood pressure on y and x plane, we have a different x values scattered here and there. First we have calculated mean. So let's say this is the different x. Here is my mean. This is my mean. This is my mean. So what we are going to calculate, x minus x bar means this is my x bar, this is mean, and this is 1x. So I'm going to calculate how much is the distance, xi minus x bar, this distance, then xi minus x bar, this distance, then this distance, then this distance. So what I'm going to do, I'm going to calculate this is, it's going to be, we are going to calculate the distance from all the different distance from the mean. We are going to measure how the different values are away from the mean. Yeah. We are going to calculate how the values are away from the mean. Is it okay? That is the numerator part. Someone has mentioned, I think they are wanted to know whether it is n minus 1 or n. Yeah. So it has been observed that if we are going to divide with n, my standard deviation will give the, it's overestimate the standard deviation. So that's why in place of n, we are going to use n minus 1, which is also known as the degree of freedom in statistics. Okay. Now other explanation we maybe, I don't think that maybe I can give at present, we have a shortage of time. So you can just assume that divided by n minus 1, so that we are in a better position to predict the population with the help of sample. Yeah. So what we are going to do, we are just calculating the distance, how the different x values are away from the mean, that we are going to calculate in the mean deviation. Now there is a possibility that some values are away from the mean, some values are below from the mean, है ना? But we are not interested whether they are below or above. I am just interested how far they are from the mean. That's why I'm going to apply this modulus value, so that I should ignore the sign negative and positive, and I will only get the positive distance. Okay. So this is about the mean deviation. Now again there was some problem in this formula. What was the problem in this formula? That this modulus value is not mathematically very strong. Fine. So in place of modulus value, we are trying to change this, modify this formula so that we will get a better picture. So in place of modulus value, what I will do, I will just use the square term. I will just use the square term. If you look at the variance formula which I have shown in the slide. So variance formula is same as the standard deviation formula. Only the difference is that in place of modulus value, I am using the square. So variance is nothing but summation xi minus x bar whole square divided by n minus 1. And this is known as the one of the best indicator to present the variation in the data set, variance. And if we talk about the standard deviation, then standard deviation is nothing but square root of variance. Is it okay? So how this, what is the, why this variance and standard deviation has been used frequently in various papers and articles? Yeah. So this is one of the best indicator, standard deviation and variation, to measure the how much variation present in the data set. Is it okay? So variance and standard deviation. Yes. So this is about the measure of dispersion and central tendency. Yeah. If you have any question up to this one, you can ask. Otherwise, I will give you a 5-minute break and then I will start the next topic. If you have any question, you can ask in chat box. No question. Why variance is preferred over mean deviation? Because mathematically what happened, if you compare the properties, now we have to see the mathematical property of modulus versus square term. Okay? So it was found that the square mathematical property of square is better than the modulus. That's why we prefer variance and standard deviation over the mean deviation. Ultimately, with the mean deviation, with applying the modulus value and using the square term, we are trying to ignore the negative sign, है ना? Because sometimes what happen, sometimes we will get the positive value when we are going to calculate xi minus x bar. We will get positive value. Sometimes we will get negative value. So when we are going to add, it will be cancelled out. Positive and negative value cancelled out, and we will not able to measure the how the different x values are away from the mean. That's why we are trying to ignore the sign using the modulus operation and using the square term. And square term is preferred over modulus value in mathematics. So that's why this standard deviation and the variance was considered the better indicator in comparison to the mean deviation. Yeah. Yes. I will give you a 5-minute break. Is it okay? Just 5-minute quick break and then I will start.
Okay, ma'am.
Yes, thank you. Meanwhile, if anyone is having question, they can write in chat box. After the session, we will discuss.
Okay, ma'am. We can pause recording for that time.
So can we start?
Yes, ma'am. Can we start recording as well?
Yes.
Yeah.
Okay. So now we are going to discuss about, so as of now we have completed the descriptive statistics, which includes the measure of central tendency and measure of dispersion. Yeah. Now we are going to discuss two techniques, which is the part of the inferential statistics. Oh, yeah. So let's say we have to find out whether the two variables are associated or not associated. This is my research question. Now you can take any two variables. Let's say if I would say, what is the relation between how much time a person has spent on exercise daily and how much is the blood pressure? Yeah. So I wanted to know the relation between the time spent on exercise per day and the blood pressure of the person. What is the relation between these two? Yeah. So this problems comes under the measure of association. Measure of association. Yes. Now in measure of association, basically, again, it has been divided into two parts. If the nature of the variable is categorical, then we can apply chi-square test to measure the association. If the nature of the variable is continuous, then we can apply the correlation to measure the association. Is it clear? There are two techniques through which we can check the measure of association. It depends upon the your nature of variable. If the nature of variable is continuous, then we have to apply the correlation. If the nature of the variable is categorical, then we have to choose a chi-square test. This is the basic thing. Yes. Now, let's say first look at the correlation when the two variables are continuous scale. So at present, what I have discussed, what is the nature of the variable? Continuous or categorical? The example which I have just mentioned. It's a continuous. So which test we can apply? We can apply the correlation because both the variables are measured in continuous scale. So we will apply correlation. So it's very simple and basic difference. Okay. So what is correlation? So correlation measure the whether the two continuous variables are linearly related or not. It's very, very important line. Two variables are linearly related or not, that we are going to measure. There is a possibility that the two variables are related, but the relationship is not linear. Linear means one unit increase in one variable, one unit increase in another variable. If variables are moving like this, we can say variables are linearly related. But every time it is not possible. Hai na? There is a possibility if I am increasing one unit in one variable, 4 unit increase happen in the another variable. So sometimes two variables might be related and the relationship may have a different curvilinear, exponential. Hai na? So there are various or quadratic relationship may be present. So the important thing is to note down that if the variables are linearly related, then only we should apply the correlation. Is it okay? Fine. So the formula of correlation is this one. So correlation is represented with the help of small r. Small r is nothing but covariance between x, y divided by standard deviation of x into standard deviation of y. What is covariance of xy? Yeah. So if you expand and open that the formula, so finally you will get this form. It's little bit complicated. It seems that it's complicated, but it's not. And there are various forms of correlation formula you will get in different textbook or online material. So what is this? X and Y are the two variable. X can be a time spent on the exercise. Y is the blood pressure. Okay? And N is the number of observations. So what we are going to do? X and Y. So just imagine I have information of a 10 individual. Excel sheet mein I have a 10 people. X, their blood pressure is given. And then their how much time they are spending on exercise, that information is given. Are you able to imagine? We have a X and Y. Okay? What we are going to do, if you just look at the first term, summation X into Y means first we are going to multiply X into Y. We will get the third column. Okay? And then we are going to take the sum. So that is my this term, N into summation X into Y. Minus summation X means we are just going to add the total X, we are going to add total Y, and then this addition final product we are going to multiply. That is summation X into summation Y divided by under root of summation X square minus summation X whole square into N into summation Y square minus summation Y square. Don't worry about this formula. Online there are lot of calculators are available. You can easily, you have to just put the value of X and Y, you will get the answer. Okay? But in which condition, which type of variable we are going to use, it's your job. You have to identify whether we should apply chi-square or whether we should apply the correlation technique. When we will apply this correlation, we will get final value. And that value is going to lies between -1 to +1. That is the range. The range of the correlation is, final value is always and always going to lie between -1 to +1. If your values are not going to lie in this one, you should check your calculation. Okay? So if your values are coming towards the -1, you can say X and Y are negatively related and the relationship is strong. Okay? If your correlation value lies towards the -1, it means X and Y are inversely related. What does it mean? X is increasing, Y is decreasing. Inverse. Okay? And if it is towards the 1, means strong. Other situation could be you are getting values towards the +1. What does it indicate? X and Y are positively related, direct relationship. If X is increasing, Y is also increasing in the same direction. And the relationship is strong. If your calculated correlation value is towards the 0, what do you say? Variables are not linearly related. Values are not linearly related. It's very important that you should say that no linear relationship. Is it okay? So it has been broadly has been given a range. If your values are, correlation values are between 0.1 to 0.3 or between -0.1 to -0.3, you can say the relationship is weak. Relationship is weak. And depending upon the positive or negative sign, you can say whether it is a negative or positive relationship. If your values are coming between 0.3 to 0.5, we are going to say the relationship is moderate. And if the values are coming from 0.5 to 1, then we can say the relationship is strong. So with the help of correlation, we can identify whether the two continuous variables are associated, significantly associated or not associated. If associated, what is the direction of the relationship and how strong or how weak they are related. So all these things we are in a position to give the answer with the help of correlation. Is it okay? So I'm just quickly summarizing. Okay. So I'll just show you the one example. Let's say we have the information of infant mortality rate at country level, and then we have a how much is the poverty at country level, that information is given. We wanted to see, is there any relationship between the poverty and the infant mortality? So because both the variables are continuous in scale, so we can apply the correlation value and we can identify the type of relationship, direction of the relationship, and the strength of the relationship. Is it okay? Correlation. Is it okay? Yeah. Now another important technique is the chi-square. Okay, that formula I'm not the question is, ma'am, we apply correlation if the variables are continuous and linearly related. How to linearity in a large data set? Yeah, so there are some techniques through which we can identify whether the variables are linear or not linear. Okay, so you can basically plot a scatter plot between x and y, and then you can see how the values are moving, whether they are moving in this direction or whether you are getting some shapes. So with the help of graph and especially a scatter plot, you are in a position to identify how the variables, whether the variables are in linear in nature or not. Okay, so one you should confirm, then you should apply the correlation. Okay, now if we look at the chi-square, I'm not going to show you the chi-square slide because we have ultimately one formula which you can get online, and it will take time to stop and share those things. I will just explain. So chi-square is applicable when the nature of the two variables are in categorical in form. Yeah. So you can take example of anything. Let's say I have one variable which is the gender of the person, and then another variable is what I should say, whether they vegetarian or non-vegetarian food. So I wanted to see what is the relation between the gender of the person and the their preference, their preferred food, whether they like vegetarian food or non-vegetarian food. So if we look at both the variables, the type of food and the gender, both the variables are in categorical in nature, है ना? Categorical in nature. So in that situation, we can apply the chi-square technique. Chi-square technique. And when we are going to apply the chi-square technique, we are ultimately going to work on the proportion of the population. We don't have the actual numbers. We have how many proportion are male, how many proportion are female, how many proportion like the vegetarian, how many of them do not like the vegetarian and they like the non-vegetarian food. So in that situation, we have to rely upon chi-square. And when we will apply the chi-square, our value, calculated value, lies between positive infinity, 0 to positive infinity. Like in correlation, our values are going to lie from -1 to +1. In the chi-square technique, our values are going to lie between 0 to positive infinity. So because we do not have a fixed range, value can be anything in positive infinity. So we are not in a position to say whether the relationship is strong, weak, or moderate. Okay? We can only say whether the relationship is significant or not, and we can say only that thing we can identify. We are not in a position to say the direction of the relationship, है ना? And direction of the relationship is actually not meaningful if your variable is categorical in nature. Yes. So this is clear, the difference between chi-square and the correlation. Is it clear? If you have any doubt, you can ask, or you all can write down in chat box. Yes. Okay. Now I will just briefly give you the sense of that regression. Okay. So what is regression? Regression is nothing but, so if you look at in the correlation, in the chi-square, how many variables we are talking about? We are using only 2 variables at one time. Yeah, whether the height, whether the blood pressure is related with the number of minutes you have spent on exercise, 2 variables, or whether the IMR is related to poverty, or the example which I have given. Yeah. So in that situation, so these correlation and chi-square technique comes under the bivariate analysis. Bivariate analysis. Yeah. Bivariate analysis, because 2 variable. And also that someone has rightly pointed out that when we do not have the idea about the cause and effect, we don't know that this is the cause and this is the effect. In that situation, we are not going to apply this one. We can only apply the chi-square and the correlation. But if we have some sense of the cause and effect, let's say I know that if we are going to exercise daily, if I spend lot of time on exercise, then my blood pressure will be come down. So I know that exercise is going to affect the level of blood pressure. Okay? So in this situation, we can apply the regression analysis. When we have the idea about the cause and effect relationship, then we should go with the regression analysis. Yeah. In regression also, we have a various kind of regressions. Various kinds of regression: linear regression, logistic regression, ordinal regression, quintile regression. There are a lot of regressions are available nowadays. Okay. Again, it depends upon what is the nature of your variable, and according to that, you are going to choose the best and appropriate regression technique to solve your research problem. Okay, this is clear. This is clear. So now what we have discussed today, we discussed about the descriptive statistics, inferential statistics. In descriptive, what all come? Central tendency, measure of dispersion. What all come in this one? Inferential statistics. When we are trying to make some inference about my house or my whatever I'm planning to this one population. So with the help of sample, I can make out the inference. Yeah. So in inferential analysis, we can apply the we can use the chi-square test, we can apply the correlation test, we can apply, there are different nature of regression variables are present, we can use those regressions. Yeah, so there are many other techniques also which comes under the inferential analysis, but due to the shortage of time, I'm not in a position to explain each and everything. Is it okay? For regression analysis also, broadly, if I would say at present, we can divide into two parts, logistic regression and linear regression. If your outcome variable is categorical, then you have to apply logistic regression. If your outcome variable is continuous, we should apply the linear regression. For example, I wanted to find out whether the woman is, what are the factors which are going to affect the contraceptive adoption. Okay. We are going to identify what let's say, what are the factors affecting the contraceptive adoption. So I can say, I can divide my outcome variable whether the woman has adopted contraceptive or not adopted contraceptive. So it is a categorical variable. In this situation, I can apply the logistic regression. However, if your outcome variable is continuous form, let's say how many times you have visited a temple. So this may be 1, 2, 3, 4, 5, 6 like that. It is a continuous variable. In this situation, we should apply linear regression model. Okay. So this is clear, the difference between logistic and linear. Yeah. Okay. Okay. So I think I should stop here, and now I should give you the idea about, or maybe you all can ask about, if you have any query, you should ask and I will give the answer.
Yeah, participants, you can put in your queries in the chat box. Ma'am, mostly the queries have been answered by you already because you have been taking questions in between. So I don't see any question. Okay, Rajvinder Kaur madam has said that please explain once more when to use linear and logistic regression.
So linear regression, just remember that in linear regression, your outcome variable should be in the linear form. It's very simple. In linear regression, your outcome variable should be in the linear in nature. So it can be anything, like number of times you have visited temple, or how many children you have. Yeah, 1, 2, 3, 4. Or maybe how many times you are spending on exercise, or how much marks you obtain in a particular subject. So when the variables are going to take the continuous value, scale value, in that situation, we can apply the linear regression. Yeah, and linear regression is the technique which comes under the multivariate analysis. Multivariate means we are going to use multiple variable simultaneously. So if we take about, let's say, my outcome variable is blood pressure. Okay. And I wanted to find out what are the factors which are affecting the blood pressure. So there are number of factors. Now, according to age, blood pressure varies. According to the type of food, blood pressure varies. According to the what type of occupations you have, that it's going to affect the blood pressure. So we can use multiple independent variable in my regression model, and I can find out which factors are actually affecting the blood pressure, which factors are playing a significant role in explaining the blood pressure. Yeah. So this is about the linear regression. Categorical logistic regression we can use when my outcome variable is in categorical form, and mostly when it is yes and no, only two category. So we can say what is whether you like vegetarian food or non-vegetarian food. What are the factors affecting the uh, liking of vegetarian food and non-vegetarian food? So vegetarian and non-vegetarian we can put 1 and 0, and then we can use in our logistic regression model. When there are several outcome variable where we can use the logistic regression, whether which type of hospital you prefer, public hospital, private hospital, yes and no, yeah, whether it is a public or private. So we can apply the logistic regression. Whether what do you think, whether you think that your health is good or not good, so we can apply logistic regression. So when the outcome variable is in categorical form, we can apply logistic regression. Otherwise we have to go with the linear regression. Is it okay? We have 15 minutes. You all can ask whatever query, whatever questions you have, you should ask, then you will able to get the idea.
Yes. In case anyone is not able to type in their query, they can raise their hand. We'll unmute that participant.
Yeah. So this is actually very vast topic, this
Yes.
linear regression logistic, because it's not a quick thing. I have just given you within 5 minutes the idea, but each and every regression technique had its own assumptions. We have to test assumption. Whenever we are going to work on any data set, it's not like without checking the assumption we should apply. For large scale data set, most of the time it's not compulsory because our data follow a normal distribution. But if we are working on small sample, we have to first check the assumption, then we are going to apply the technique. We will get estimate, we are going to write the interpretation. So basically all these techniques, this linear regression, logistic regression, then chi-square, correlation, these techniques come under the inferential statistics, because we are going to calculate we are going to predict the situation of population with the help of our sample.
There's a question which has been answered by Rajendra ma'am, and the question was related to formula for regression, and Rajendra ma'am has said that you can use SPSS. So,
yeah. So the formula of linear regression is the simple linear line formula. Yeah. What is the simple linear line formula? Y is equal to A plus BX. That is the this one, linear line. So this, on the basis of this one, I will just write in chat box. Okay. So linear regression y is equals to A plus BX. This is the formula. Okay. Now what is y? Y is your outcome variable. Outcome variable, it can be blood pressure, it can be height, it can be how much marks you obtain in statistics. Yeah. Y can be any outcome variable which is measured in linear form. Yeah. What is A? A is nothing but the intercept. When you are making a line, it going to touch the this one, that y-axis, that is your intercept. And what is B? B is nothing but the slope of the line, whether the line is like this, whether the line like this, that is the slope. And X is the independent variable. So let's say if I wanted to find out what is the effect of my outcome variable is, let's say y is equal to children ever born. Children ever born means how many birth woman has given. One has reported 0, 1, 2, 3, 4, 5, like that. In rural area, maybe 7, 6 also. Okay. So this is the y is the, let's say, children ever born. and let's say X is the education. How many years she has spent in schooling? 1 year, 2 year, 3 year. Yeah. So I wanted to find out what is the effect of year of education on children ever born. Yeah. So this, I have the assumption that education is going to affect, this is the cause, and it's going to affect the children ever born. Yeah. So in that situation, we can apply the linear regression, and in that situation, we will get the idea that what is the effect of education on children ever born. Now, interpretation and all, it's not possible. I cannot explain. We have to have a one table, and with the help of table,
Maybe we can have another session with you sometime for this learning regression, both the types of regressions. Ma'am, why by any chance can we call it dependent variable in this like case wise?
why it is called as a dependent variable.
Is it so? I mean, because we have learned already independent and dependent variables. So in this case, the outcome which we are about to calculate.
This is
Okay.
dependent variable.
Dependent variable.
Dependent variable because it depends upon the level of the education. If I'm going to change the education, children ever born will change. Hai na?
Yes.
So y, which is my outcome variable, is the dependent variable, and independent variable is maybe education, it may be the caste, it can be religion, it can be anything. So we can take multiple x values in the regression. It's not only education. We are going to use number of variables. That's why it is known as a multivariate analysis. Multiple variable we are going to use, because
So in case of multivariate, multiple independent variables we are taking.
yes,
right?
yes. Our outcome variable, dependent variable is one, but independent variables are many. It can be 1, it can be 2, it can be maybe 10 or 15 also.
I
Yes.
don't see any more questions. So I think we can proceed towards the end of the session. So yeah, today we had a very interactive session where ma'am did a hand holding through the journey of measures of central tendencies, measure of dispersion, measures of association. So before we conclude this session, I would like to propose a formal vote of thanks on behalf of our institution. Thank you, Priyanka Dikshit ma'am, for such an informative session. This 10 days virtual workshop would not have been possible without the support of which has been extended by a proactive management and the guidance of our principal, sir. So thanks to our management and principal, sir. We thank you, our vice principal and IQAC coordinator, Dr. Liji Santosh, and vice principal, Professor Sandesha Shetty, for their constant support and guidance for executing it. I'm thankful to all our vigilant technical team, coordinators, teaching and non-teaching staff members for all support they have rendered. Above all, our special thanks to the interactive and inquisitive participants for their encouragement. Thank you very much. The next session will be on SPSS by Dr. C.P. Gupta. So see you at 2 p.m.
Please ask them to download the version. Thank you, Priyanka ma'am. It was really so
Thank you, everyone.
intriguing and
Thank
so
you,
good.
ma'am.
Thank you so much.
Yeah, thank you.
You saved us. Thank you.